Alright, so in a previous video I explained what a radian is, and that would be this angle theta right here. This angle theta equals 1 radian because the angle intercepts, this central angle intercepts 1 radius length on the circle here. So, and you notice that it takes a little more than 3 of these radian angles to make it around to 180 degrees. So there will be 1 radian, 2 radians, 3 radians will make it to about right there. And the exact number of radians that equals 180 degrees, it takes 2 pi, a little more than 6, 2 pi of these radius lengths to make it around the circle, which means it also takes 2 pi radians to equal 360 degrees. So I guess I could start with 360. So 360 degrees equals 2 pi radians. And in trigonometry, you don't use the radians. The radians unit is kind of just assumed. You just write 2 pi. You don't, it's assumed that when you're referring to an angle in trigonometry as some multiple of pi, it's assumed that you're talking about radians. So that would mean that 180 degrees, of course, would be pi radians. And that 90 degrees, well, 90 is half of 180, so 90 degrees would be pi halves radians. And 60 degrees, 60 is a third of 180, so 60 degrees would be pi thirds radians. And 45 degrees is a fourth of 180, or half of 90. Half of a half is a fourth, so 45 degrees would be pi fourths radians. And finally, 30 degrees would be 30 degrees is 1/6 of 180 degrees, so that would be pi sixths radians. Now, I did these specific angle measures because these are the angle measures that are going to be most important for you to be able to work with, because all of these angles will be related to the 2 special triangles that you already know the ratios to, or should know. 45, 45, 90 right triangle, and a 30, 60, 90 right triangle. You should know the ratios of the side lengths of those 2 triangles. Now, it's very easy to convert from degrees to radians and back and forth just using this conversion factor. 180 degrees over pi radians, or pi radians over 180 degrees. If you're given radians, both of these numbers, both of these ratios, because the numerator and the denominator are equal, both of those ratios equal 1. So say you wanted to convert some number of, that's great. This is it's 2 videos in a row that that instruction came through. But anyway, if you wanted to convert some number of radians into degrees, you would use this conversion factor. Just multiply that number of radians by this, which equals 1. When you multiply by 1, you're not changing the value of the number, you might just be changing the units. and you'd be changing radians into degrees. If you want to change degrees into radians, you would use this conversion factor over here. Just multiply by this version of the number 1. And the degrees units would cancel out, and you'll be left with radians. Let's say, for example, we wanted to know what 100 degrees was in radians. Well, we simply multiply it by pi radians over 180 degrees, which equals 1. The degrees units cancel out, and so you're left with 100 over 180 times pi. The degrees units cancel out, and you're left with radians. So that will be 10/18, which reduced to 5/9. So 5/9 pi radians. Vice versa, if you wanted to convert, say, 4/5 pi radians into degrees, you would just multiply by 180 degrees over pi radians. And the radians would cancel out. And you'd be left with 4/5 times, and also the pi's would cancel out, as you see. So you'd move 4/5 times 180, which would be a fifth of 180 would be 36, and 36 times 4 would be 144 degrees. Okay, so this will help you visualize these radian measures on a circle where we can map out, where we can see them as degree measures and how they compare. So first of all, I'll remind you what 1 radian looks like. There is a 1 radian, which is about 56 degrees. Not exactly, but about 56 degrees. That 1 radian is that arc is exactly the length of the radius, remember. Okay, so now I'm going to hide that radian arc, and well, remember that all the way around took exactly pi of those radian angles, 2 pi rather. So half of that would be pi radians. So the 180 degree markers are, you've got 0 degrees, which is also 0 radians, 180 degrees, pi would be right here, and 360 degrees, 0 corresponds to 2 pi. It would also correspond to 4 pi, and so forth. Now, well, what about 90 degrees? Well, 90 degrees, that would be half of pi radians, or pi halves. What about 270 degrees? Here, this would be 1.5 pi, or pi plus another pi halves. So 1 pi halves, 2 pi halves, which is pi, and 3 pi halves. So here would be the 90 degree markers on the circle. Pi halves, pi, and 3 pi halves. Okay, well, if we take half of that pi halves, we go down to 45 degrees. Half of pi halves is pi fourths. So pi fourths will be here. And 135 degrees, well, that's pi fourths less than pi. Pi fourths less than pi would be 3/4 of pi, or 3 pi fourths. 225 degrees will be pi fourths more than pi. Pi plus pi fourths. Think about what that will be. That will be 5 pi fourths. And then pi fourths less than 2 pi will be pi fourths less than 8 pi fourths, or 7 pi fourths. So we've got 1 pi fourth, 1, 2, 3, 4, 5, 6, 7 pi fourths, and then of course 8 pi fourths. Okay, now what about 60 degrees? 60 degrees, that's a third of pi, so this would be pi thirds. And double that to 120, you've got 2 pi thirds. Down here at 240 would be, well, pi is 3 pi thirds. So this would be another pi thirds, 4 pi thirds. And then 300, 5 pi thirds. So the 60 degrees, pi thirds, 2 pi thirds, pi, 4 pi thirds, 5 pi thirds, 6 pi thirds, if you will. And then finally, the 30-degree angle. Well, 30 degrees, 30 degrees is half of 60 degrees, half of pi thirds is pi sixths. So that would be pi sixths. This would be 2 pi sixths, 3 pi sixths, 4 pi sixths, 5 pi sixths, 6 pi sixths, which is pi, 7 pi sixths, 8 pi sixths, 9 pi sixths, 10 pi sixths, 11 pi sixths. There's the 30-degree. Every multiple of 13, every multiple of 30 degrees. So these are what this unit circle thing was talking about. Pi sixths, pi fourths, pi thirds, pi all those. They're just multiples of 30 or multiples of 45. Now, in another video, I will show you where these coordinates come from. Super, super easy.